The essential questions for this lesson are: how do stoichiometric ratios relate reactants and products in a chemical reaction? How are stoichiometric ratios used to predict the amounts of reactants and/or products? And how can dimensional analysis be used to express stoichiometric ratios? By the end of this lesson, you should be able to use stoichiometric ratios to convert from mass of one substance to mass of another, given the balanced chemical reaction. This is our expanded stoichiometric mole roadmap. It's almost identical to the other mole roadmap, but it has the added step of moles of one thing to moles of another, using the coefficients from your balanced chemical equation that we talked about in the last lesson. In this lesson, we are only going to be doing mass of one substance to mass of another. So we're going to be following the roadmap along this path. Remember, in order to convert from mass to moles, and from moles of something back to mass, we use the molar mass. So you will need to find the molar mass of both of the substances we're dealing with. Your first step will be converting from mass to moles by dividing by the molar mass, multiplying by 1 mole over the molar mass. The next step will bring you from the mass of one substance to the mass of the other that we're looking for, using the coefficients from the balanced chemical equation. And the final step will be multiplying by the molar mass of our second substance to convert from moles to mass. If we use 5.73 grams of lithium oxide, how many grams of lithium should we expect to obtain? We're told that the balanced chemical equation is 2Li2O yields 4Li plus O2. Again, we're only going to be dealing with 2 substances at a time. This tells me how much lithium oxide I start with, and I'm looking for how much lithium I end up with. That means the oxygen can be completely ignored for the purposes of this problem. So again, we always start with what we're given. We are told we are using 5.73 grams of lithium oxide. Now, the first thing I need to do is I have grams. I need to get it to moles. So I'm going to do my parentheses. And since I started with grams of lithium oxide, I need to put the grams of lithium oxide on the bottom. The molar mass of lithium oxide is 29.8814. So that's going to go on the bottom so that my units of grams of lithium oxide cancel out. That is the mass of 1 mole of lithium oxide. So 1 mole of lithium oxide goes on the top. Notice this is not the coefficient. This is 1 mole and the mass of 1 mole. That gives me moles of lithium oxide. The next step I'm going to do is using the coefficients to convert from moles of lithium oxide to moles of lithium. This is where I'm going to use my coefficients. From the equation, it tells me that I use 2 moles of lithium oxide to create 4 moles of lithium. This lets the units moles of lithium oxide cancel out, and I'm left with units of moles of lithium. However, this is asking me how many grams of lithium I should end up getting. So I need one more step to convert from moles of lithium to grams of lithium. Since moles of lithium is on the top, I need to put the moles of lithium on the bottom, and the mass of 1 mole of lithium goes on the top. Again, this is the mass of 1 mole of lithium. So the units moles of lithium cancel out, and when I plug this into my calculator, it's 5.73 times 1 divided by 29.8814 times 4 divided by 2 times 6.941 divided by 1, and that gives me 2.66 grams of lithium. Using the same beginning information, let's figure out how many grams of O2 we should expect to obtain. Again, we start with what we're given, 5.73 grams of lithium oxide, parentheses, and a line. I need to do the exact same thing. I am going to be converting from grams of lithium oxide to moles of lithium oxide. So the molar mass of lithium oxide on the bottom, so that the units of grams of lithium oxide cancel, and moles of lithium oxide on the top. My next step is to convert from moles of lithium oxide to moles of what I'm trying to find, which is oxygen. So again, the coefficients, 2 moles of lithium oxide produces 1 mole of oxygen gas. So the units moles of lithium oxide cancel out, and I have moles of O2. But I'm looking for grams, so one more step to take me to grams. And I'm going to use the molar mass, and I know that 1 mole of O2 has a mass of 31.9988 grams. Units of moles of oxygen cancel out, and I'm left with the mass of oxygen. So 5.73 times 1 divided by 29.8814 times 1 divided by 2 times 31.9988 divided by 1 gives me a total of 3.07 grams of O2. Now, does this make sense? The law of conservation of energy states that whatever mass I started with, I must end up with. So if we look at the reactants and products, the only reactant I started with was lithium oxide, and I had 5.73 grams of that. So I started with 5.73 grams of matter. And when we did the calculation, we found that there would be 2.66 grams of lithium formed and 3.07 grams of oxygen formed. When you add those, you do end up with the same mass as what you started with, 5.73. So remember, when you're converting from mass of one thing to mass of another, it will take you 3 steps. The first step is using the mass of 1 mole of the substance that you're starting with. The second step is going to use the coefficients from the balanced chemical equation. And the third step is going to use the molar mass of the substance that you're trying to find. Remember, whatever substance, whatever unit you start with must go on the bottom of the next fraction.